Good morning, my dear children. Yesterday we studied that how is sound produced. We have understood that vibrations are the cause for producing sound. We try to study the various aspects of vibrations through a pendulum, and we have also studied certain terms yesterday which we'll very quickly revise again, right? The terms were amplitude. So amplitude is the maximum distance from the mean position to one extreme position. This we have done yesterday. Then frequency. Frequency is the number of oscillations, or you can say number of vibrations that are made in 1 second. So that is frequency. The number of times the pendulum is oscillating to and fro in 1 second. That is frequency. Time period, as the name suggests. Time period is a time taken to complete one vibration. Right? That is time period. And then we have done terms like loudness and pitch. Now loudness we have understood depends upon the amplitude. How far is the vibrating particle from the mean position, right? If the distance from the mean position is more, the sound is going to be loud. If the distance of the vibrating particle from the mean position is small, then the sound will be low, right? So loud sound and low sound depends upon the amplitude. Then we did a term called pitch, low pitch or high pitch, right? So pitch depends upon frequency, right? The number of times, what was frequency? The number of times the particle is vibrating in 1 second. If the number is more, frequency is more, then the sound is going to be more shrill. It's going to be high pitch. But if the frequency is less, that is number of vibrations in 1 second is less, then the pitch is going to be low pitch, right? Less shrill, right? So this we have done yesterday. Now today you open page 154, and from that page we are going to study that do all vibrations produce sound, right? Or in other words, you can say, are all sounds audible? Sound is produced by vibrations, and that means what effect these vibrations have on an ear. Are we able to hear all kinds of vibrations, or there is some limit to it? So in human beings, we can comfortably hear to the vibrations of 20 hertz. What is hertz? Hertz is the frequency of, it's a unit of frequency. We have done this yesterday. So from 20 hertz to 20,000 hertz. 20,000 hertz is the maximum frequency to which a human ear can perceive. The human ear is sensitive to the sound produced between the frequency of 20 to 20,000 hertz. And this audible limit is also called sonic vibration or sonic sound. The word sonic relates to sound. So this is sonic vibrations. Now there are certain vibrations, certain sounds which are much higher than 20,000, but we are not able to hear them. There are some animals who can hear them, like dogs can hear till 40,000 hertz, right? So we have developed a special whistle called Galton whistle, and through this whistle the dogs can hear that whistle. They're trained to hear that whistle, but we can't hear it. Then there are animals like bats. The bats produce sound of vibrations from 50 hertz to 80,000 hertz, right? And they have this facility because their eyes are weak, and how to detect their food, insects. So they give out such vibrations, and such vibrations are, they strike the insects and it come back to them, and they are able to detect their prey. Similarly, these dolphins also can detect their prey with the help of strong vibrations. So we have understood, we did sonic vibrations. Sonic vibrations, the range between 20 to 20,000 hertz. Now, these vibrations more than 20,000 hertz are called ultrasonic vibrations. So, as we just discussed, dogs and bats and all, they can hear sounds which is even more than 20,000. So the ultrasonic. So we're going to again do this with the help of a presentation, which like we did yesterday. Today also we are going to do that presentation. Now you come to page 155 of your books, and there's some very interesting facts here, with the help of which you try to understand that how these vibrations help in not in only hearing, but they have got so many other uses also. So the first one is the ultrasonic vibrations. They are used for homogenizing milk. Homogenizing milk means the particles in the milk are of the same size. So the fat particles are breaken up with the help of the ultrasonic vibrations, and they break down to form small molecules, and this is how the entire milk will have the same size particles, and this is called homogenizing. So they are used for homogenizing milk. Second is they are used in dishwashers, right? In dishwashers, the soap and the water, with the help of these ultrasonic vibrations, they strike the utensils, right? They rub against the utensils and they make them clean. Then third, they are used as repellents, like rats and cockroaches. If you want to drive them out, we used certain machines which produce these ultrasonic vibrations, and these vibrations cause a sort of a depression in these animals and they run away. So this is how we can use them as repellents. Then they are also used for internal organ imaging. You make an image of the internal organs of the body. So sometimes we go for sonography, right? And through sonography, we take the picture of the internal organs of our body, and we can detect if there is any problem there. So this is how these ultrasonic vibrations are also used for health purposes. Then they are also used in detecting flaws in metals. If there is any flaw, these vibrations are sent, and the thickness of the metal, if there is any problem in the metal, any defect in the metal, can also be detected with the help of ultrasonic vibrations. So these are some interesting facts that we have understood. Now under this we have got some questions here, children, and I would suggest that you go through these questions and answer them, and then we're going to discuss them later, right? Now the next topic that we're going to do is sound needs a material medium for their propagation. Now what is this material medium? Material medium. We know that all matter is made up of molecules, right? So material medium means, do these vibrations need some molecules to travel, right? How do these vibrations travel? How do they move? So do they need any molecules? So this is how this is what we are going to study in this topic. So let us start with our slide presentation, and through that also we are going to understand these things.